So welcome to this session. My name is Jessica and I'm the course advisor here at the University of Manchester for our PG Certificate in Clinical Bioinformatics. So I'm going to hand over in a second to our panel. We have a great panel joining us today. We have our course director, Andrew Davies, and our unit lead, Andrew Devereau. So, Andrew, over to you for our first section of our today's session.
Thanks very much, Jess. Welcome, everybody. I'm Andrew Davies. I'm the course director for the course in Clinical Bioinformatics, this PG certificate. And actually our fourth unit on the course is all focused around applied next generation sequencing. So we're going to cover some of the areas that we'll cover in that unit here within this webinar, and obviously just give you a link if you're interested at the end to the course and a bit more detail. So I guess what we wanted to focus on today was how really next generation sequencing is impacting healthcare professionals, the challenges, the benefits, how things have changed over the last few years. So both myself and Andrew over the last few years have been involved in training the clinical bioinformaticians working in the NHS. And in fact, actually, as part of what we do within the course delivery, we interview a number of our clinical colleagues, quite often in the Manchester Centre for Genomic Medicine, where we sit actually in Manchester very, very close to, and we create these kind of case study videos. So some of the things we're going to talk to in this webinar are some links to some of those materials that we use, and we'll expand on those a little bit for you as well. And if you have any questions, do pop them in the chat. So I guess just to start off here, so you can see this is Sandy Bhaskar. He's actually the principal clinical bioinformatician working in the Manchester Genomic Laboratory Hub. And we interviewed him some time ago to really explore how the role of the clinical bioinformaticians is changing, what they're kind of looking at. So perhaps, actually, I'll just, so I guess to highlight the way things have changed over the last few years since we've been training clinical bioinformaticians. So back when we first started, gene panels where you look at a focused number of genes linked to a particular clinical phenotype were really just coming through. And since we sort of started the training provision, we've now moved into looking at clinical exomes. So they're focused exomes where you look at a number of inherited genes that link to particular Mendelian phenotypes, so around 5,000 to 6,000 genes typically on those focused clinical exomes, and also now beginning to look at whole genomes. And we'll talk about that in a bit more detail, because obviously not everybody that comes to a clinical genetic laboratory will undergo whole genome sequencing. And of course, part of the background to why we're now doing that is because of the 100,000 Genomes project, which was a landmark project within the UK. So if we begin to think about how next generation sequencing is now being used clinically, things have changed quite a lot actually in the last couple of years. So we've mentioned we're now doing whole genome sequencing, and I'll expand on that a little bit more on the next section. We're now, for a long time, we've been focused on looking at single nucleotide variants. So they're single changes in the bases within within the genome. We now also look at copy number variants. We've found over the last few years that they're particularly important in Mendelian diseases, and actually so now we have pipelines with particular tools inserted within them that actually will focus and look at analysing copy number variant analysis. We're now beginning to do cDNA analysis, so that involves changes as well, and updates to the bioinformatics workflows or pipelines where we do the analysis of the next generation sequencing data. And as I've mentioned, we're doing panel testing, which might look at just a few genes linked to a specific phenotype for a very specific phenotypes. But when there's a much more heterogeneous phenotype, we might look at up to hundreds of genes within those panels. Look at the next bit, perhaps, Jess. So if we begin to think about looking at overcoming the challenges really, and what sort of skills are required by a bioinformatician. So we've mentioned there's been lots of changes over those last few years, and every time we introduce a new clinical service, we need a new bioinformatic pipeline. If it relates to particularly to the next generation sequencing, we have to update those pipelines to add in new tools that we're looking at. Then we'll need to validate them against known particular mutations, known sample sets, and then we implement them and put them into practice. And of course, the importance here is as opposed to a research environment is we're looking at delivering a service for a patient. So we absolutely have to be really sure that these pipelines are sensitive and accurate. And one of the things that we do within the genetic laboratories, as well as looking at single nucleotide variants, we also look at, we offer testing that looks at somatic variants in tumour samples for cancer patients. And these can be used, this sorts of tests can be used in a variety of ways. So we might use the results to personalise treatment for the patient. We might use it for helping with prognoses or diagnoses. And one of the challenges with somatic mutations or somatic variants is that they're often present in very low levels in very heterogeneous samples. So when we're looking at the next generation sequencing data, one of the challenges there is really dissociating the actual variant itself from the background noise in the sample. And this comes back to the real sensitivity of the pipelines that are required when we're looking for somatic variants. So that gives you an example of the sorts of challenges that bioinformaticians face. And the other main challenge is just the speed at which the technology and the pipelines have to be updated and changed. That's reflected in how we teach the course. I think we update our materials almost on a yearly basis because things are moving so rapidly and changing so rapidly. We have to reflect that in what we teach to our students too. I think that's the first section, just what I wanted to mention about those aspects. Okay, so then this next section, we have an example of a clinician that we've done some work with to interview. So this is Dr. Tracy Briggs. Tracy's a senior clinical lecturer at the University of Manchester and also an honorary consultant within the Manchester Centre for Genomic Medicine, and has her own research interests, in particular rare genetic disorders. And when we spoke to Tracy, she sort of said to us, really, there's been a lot of changes in the last few years, and a lot of changes actually that have really impacted on the clinical geneticists and the clinicians that are delivering genomic services. So when she talks to a patient, and obviously this is, again, coming back to the key difference here from working in a research bioinformatics environment, is that there's always a patient that's involved and hopefully waiting to get a diagnosis at the end of what the laboratory, the analysis that the laboratory is undertaking. So from a patient perspective, there are 4 potential kind of outcomes really when undertaking genetic testing. So it might be, unfortunately, that actually nothing, so there's no particular underlying molecular diagnosis that's able to be achieved, so they find nothing. They might find a variant, but it might be what's called a variant of uncertain significance. And that means that there's actually insufficient precedence in the literature, or it's been seen, it's not been seen before, or insufficient numbers of times, that we can't actually sufficiently say with enough evidence that we can it's actually underlying that genetic condition. The other scenario is we might need to do some further analysis or some further testing to support a molecular diagnosis. And the other thing that can happen is that we find an incidental diagnosis or what's called a secondary or incidental finding. And what that means is often when we're looking at huge panels of genes or even a clinical exome, we're looking in other genes that, whilst might be clinically important, aren't related to the patient's phenotype. So sometimes we might find a change in those particular genes. And that takes a lot more explaining, a lot more consenting as far as looking at those huge panels of genes using next generation sequencing, because we have to make sure that the patient understands the ethical considerations of that kind of outcome. So in terms of just thinking about sort of how the future's changing, how the roles of clinical geneticists and other clinicians are changing. So we've now got much more wide accessibility to whole genome sequencing. As we've mentioned, it's not always done. We'll talk about that. There are still some very specific examples where we'll just look in single genes with a clear link to a particular disorder. But we've got this idea now of mainstreaming genomic medicine, so there are much more wider groups of clinicians that are now referring to genetics clinics. And what that means is, as far as the changing role of clinical geneticists, is that the movement of testing more patients, the movement of looking at more genes, more exomes, means it's changed the way in which clinicians work. So now we have generally much broader teams that they're part of, much more interdisciplinary working. So the clinician might work with bioinformaticians, they might work alongside the clinical scientists, other genetic counsellors, and there'll be a lot more coming together as multidisciplinary teams, quite often to try to discuss some of these much more complicated variants where they're either complicated because we've not seen them before, or they're in regions of the genome that we actually know a lot less about. So we've actually had to put in much more training and education to cope with that. So Health Education England have commissioned a whole programme in genomic medicine, and in fact Manchester University delivers a programme in that area. So we've trained a much broader workforce to enable them to interpret and really work with that genetic data that's coming through. So the hope, of course, is that we're looking at many more genes. Well, the hope is that we'll improve the diagnostic rate, so we're able to provide a diagnosis back to the patients in many more cases. But of course, what would happen many years ago, and still does happen to some extent sometimes, is there was quite often what was known as a diagnostic odyssey, where patients would undergo rounds and rounds of not just genetic testing, but other kinds of testing to try and enable them to reach a clinical diagnosis. And often a large portion might remain undiagnosed. So where are we moving next? We mentioned we're moving into copy number variants. We're looking at much more non-coding variants, and the reason we can do that now is because we're sequencing the non-coding regions. So that's not just the exomes, but the whole genome now. And that's important because quite often Mendelian disorders are recessive, so there'll be two variants present. So that means if we found one, we still need to find a second variant, and looking in those non-coding variants can often be the clue to finding that second variant. So that's been a really important change in what's happened. Just trying to think. Yeah, so I think they were the main points that we wanted to mention on that aspect. So I think it's over to Andrew.
Thanks, Ange. Yeah, so well, welcome everyone. So I'm Andrew Devereau. I'm one of the unit lead for Unit 4. So we can pick up some of these points that Andrew's been making there. And if we look at Simon Ramsden here, who's a clinical scientist that works in the Manchester laboratory, and the role of our clinical scientists is very much now to work with the bioinformaticians and with the clinicians and with the genome technologists to develop, to design tests, to come up with the right strategies, to generate the right data which can be used for the clinical, for the treatment of the patients, to give to the clinicians to actually help the patients. And if we look at how things have changed over the last few years with NGS, because we have these NGS technologies now, Simon now has a lot more strategies that can be brought to bear for different situations. So as Andrew's already mentioned, we have our single gene tests, our panels, small panels, much larger panels are available, clinical exomes, and now we have in some cases whole genomes as well, which can be used, and a much broader range of the types of variants and the types of diseases that can be treated. So the impact of NGS has been that what was a very small area of genetic medicine, only applicable to a small range of genetic diseases, has now broadened to a much broad mainstream specialism, where we're able to provide tests for anyone with any sort of inherited disease. And that's led to a number of challenges. So there's a real need for new skills. So yeah, as Simon has said, they need to learn a completely new skill set. So everyone involved has to learn about these changing bioinformatic processes and changing NGS technologies, how to interpret genes in these much broader and less studied genetic diseases. And then the standardization, how to apply technologies and how to apply the data analysis in a standardized way that's fit for clinical use. And then there's these new collaborations, so there's much broader range of people that have to be worked with, from the clinicians in areas who've never had any particular involvement in genetics before, and to the bioinformaticians and the clinical scientists, all working together with the clinicians in ways that they haven't worked before. So I think we can go on to the next slide. So Unit 4 of our PG Cert course is our next generation sequencing course, and it's very much based around the practical knowledge and skills that are needed to address some of those challenges that we've been talking about. How to understand what these technologies are, these new technologies, and where the data comes from and how it's analysed. You can see on the screen here an example of the kind of data that you'll be working with in this unit. So this real practical NGS data. So if we look at the course content, so we'll start off looking in 3 parts really. First of all, looking at the theory and background. So we'll look at which technologies are being used at NGS and which are coming, how they generate data, what's the process that goes on to generate the data that we're going to analyze. And then when we have our data, what are the stages of bioinformatic analysis that we need to go through to make clinical sense out of that data. And with that knowledge, we move into part 2 of the unit, where you'll be doing some practical NGS work. So you'll be taking a real full-scale set of whole genome data, or whole exome data rather, and you'll be going through an analysis using these online tools, the one that you've just seen on the screen before, to carry out the same kind of analysis that a bioinformatician would apply in the laboratory, to go through the stages of quality control, of mapping and finding variants and annotating them, and finding the variants which can be linked, put forward for clinical analysis to see if they are in fact causative for the patient. Do they form the molecular diagnosis? And then finally, in the last part of the unit, you'll be looking at a few of the different applications. So the way that we apply NGS, so the whole exomes, the whole genomes, and the different panels, and where they come from and how they can be designed. We'll also look at copy number variants, as Andrew mentioned earlier. These are kinds of variants which are being brought into this NGS analysis world now. So we'll look at CNV analysis, copy number variant analysis. And finally, we'll look at the ethics and governance that underpin and overarch, if you like, this whole area, and which are vitally important for anyone working in the bioinformatics to understand if they are to deliver safe and effective patient care. Okay, so I think, Jess, are you going to talk about the assessment?
Sorry, trying to unmute and manage a slideshow too much. Yeah, I think it would be useful to hear a bit about the assessment process. And you were mentioning earlier, Andrew, before we started the presentation, the sort of the application of the presentations and the reports. Perhaps it'd be useful for you to talk in a bit of detail about those.
Yeah, absolutely. So so the first part of the assessment is our contribution to discussion boards, and we'll be having discussions on a broad range of topics. But when it comes to the presentations and the clinical report, that'll be very much based on you carrying out a real practical analysis of a full-scale set of data from a whole genome, a whole exome sequencing analysis, of finding those clinical variants and putting them forward in a clinical report. So it's a very practical and real world based assessment.
Great, and I know a lot of our sort of candidates are really interested in hearing in more detail, because many people can't imagine how you can undertake an online course and sort of have proper assessment, but obviously this course has been designed as a fully online adaptation to a real world problem. So I'm just, sorry, you're going to say, Andrew?
No, sorry, carry on.
So just move on to talk now about the application process for this unit. So as you'll see, I'm just going to go back a section here. Sorry if anybody feels seasick. We've got a few different options available for this course here. So the course is available as the full PG certificate, which is 12 or 24-month option. So this means a flexible route where you can either extend your learning for 2 years, or if you're really keen to learn all of your skills as soon as possible, this course can be studied over a 12-month period as well. The Unit 4 can be taken individually as a CPD unit. Some students prefer to do this, or they prefer to take the full PG certificate. It's really up to you. The CPD unit will run from February till May, and it's a fully online and part-time course. So we typically expect that our students will spend about 15 to 20 hours per week studying independent study. This workload might vary depending on what point in the 3 months unit this is. There might be some weeks which have a heavier workload, some which may be slightly lighter. We have had recommendations from our current students, though, that the most effective way of learning and sort of consolidating that knowledge is little and often. And I'm sure, Andrew, you can agree with that, that it's often the best way to take a bit of time each day to put towards your development. So I'm just going to talk briefly about the application process. I'm here to support you during your application process. You can get in touch with me to discuss the necessary documents which you will require. So you'll need your personal statement, which is a supporting statement to tell us why you're looking to apply for the course. So this should detail your motivations to study, what brought you to apply for the course, and what you hope to achieve from this course. We do look for a UK 2-1 for our postgraduate certificate or an international equivalent, but do get in touch if you have slightly lower than this, and we can discuss this with Andrew, our course director, and we can see whether there are any exceptions which can be made. But yeah, so any questions, get in touch with me and we can discuss your application. But going back to the content of our session today, I think it's been really informative to hear about the advancements which have been made to next generation sequencing. So thanks, Andrew, for telling us all about that. But now I'd like to open the room in case there are any questions from our audience. Feel free to pop them in the Q&A box if you do have anything in particular that you would like to discuss. I can see we've got one come through. So one of our attendees has asked a question now. So will NGS detect some imprinting disorders like DNA methylation in the future? Andrew, I'm not sure if either of you wants to answer that.
Yeah, it's a really good question. I have to say, I mean, we do a lot in terms of supporting the current adaptations of pipelines, etc. And so far, we've had nothing that's really looked at DNA methylation disorders or sort of with a particular epigenetic focus. So these are, you know, kind of, yeah, you're talking about affecting the epigenetics here and modifications. I think much more of that will start to come through. For sure, and I've heard people starting already to look at RNA-seq type pipelines. Yeah, I don't think I've got a better answer than that right now. I don't think anyone's doing it right now, but I think it could be definitely feasible. Andrew, have you got any further insight?
No, I haven't really got anything more to add to that, Andrew. I think very much feel the same as you, that it's something that I have heard talked about, and something which I think will be coming along. I think particularly, I mean, I didn't really go into long read technologies previously, but I think one of the technologies that's been around in the background is this third generation, this kind of long read sequencers, and I think those are one of the technologies where, you know, new applications of that nature are being looked at. But I know no more about it than that, I'm afraid.
That sounds like a really interesting question. One of our attendees is ahead of the time. So just while I see if any other questions come through, I'm just going to launch 2 last polls for you to answer, our attendees. So I'm really interested to hear in what sessions you would like to see from us in the future. We want to provide the content for you which you're looking to hear the most. And also how you found today's session. If you have any other feedback, please do send us an email and let us know in more detail, and we're happy to hear that. But Andrew, is there anything else you'd like to drop on today while we've got you? Anything else you'd like to mention about your experience teaching the course, perhaps, or of this unit in particular?
I mean, maybe one thing it's worth mentioning, it's sort of struck us as interesting, is I guess we've been sort of embedded in this teaching of the clinical bioinformaticians, and we've kind of grown. Our knowledge has grown as the genomic medicine service has grown with the changes in the UK. So, you know, maybe people are thinking, oh, this is not where we're at the moment, etc. So I think we are mindful of that. And one thing that I think is a real actual great aspect of the course is the way we embed the discussion boards. and link that to the real world examples. So, you know, we'll really get you working in groups, in teams, discussing those examples, sharing your experience from your different areas. And I think, you know, in that way, you can really learn from others and learn from us as facilitators, course leads, etc. So I think that's been a strength of how we've kind of developed things. I don't know, Andrew, do you want to add anything?
Yeah, I mean, it's been interesting that we've had to do a lot of teaching, which we normally would have been doing face-to-face in our university courses. We've been doing in exactly the same way as we'd be teaching on this course, you know, remotely, with using a lot of online material and then a lot of this discussion boards and you know, working in groups, but separated and only using tools to communicate. And it's worked really well, and I think it shows that the way you work on this course and the way you're able to access tools like the bioinformatic pipeline tool that we use for doing the analysis of data, you can access this in exactly the same way as people do when they're actually attending face-to-face courses. So and as Andrew said, you know, one of the important things is working with other people and bringing all their experience. There's a vast range of experience that they bring into these courses, and I think we found that people are able to share that experience really well using the kind of communications that we've been using on this course. So it's a great experience for everyone to work together and learn a lot from each other, and I think it works really well with the discussions that we have.
Great, thank you, Andrew. That's really interesting to hear. Just have one more question about the start date of the course. So the intake for the PG certificate is in May, so you can submit an application for the full 4 units of this course now. You can get in touch with me to discuss how to do that directly. But for the Unit 4 in particular, that starts in February. The next intake of that course individually as a CPD unit is in February 2022. So Andrew is just starting this intake's teaching of this week, which I'm sure he's very excited about.
We're all ready and keen.
So yes, this will start in the coming year, but this resource will be accessible throughout the next year as well. So I've just seen the answers to our polls, and we've had a few people who have mentioned that they are interested in hearing more particularly about the programming session, so a Unit 3 session, for example. And coincidentally, we have a session coming up in about a month's time, almost to the date actually, about becoming an expert in programming. So we'll be joined by our course lead, who's called Pete, and he will talk us through whether it's even possible to become an expert in programming. I guess that's more the theme of the conversation which we'll be having, but you can register for that session here. I know it seems quite a long way in the future, but I thought I'd get the date in your diaries soon. But yeah, thank you all for joining us today. I hope it's been really informative, and I will circulate this recording as soon as possible. But yeah, that's all from me. Thank you everyone, and have a great afternoon.
Thanks everyone.
Thank you very much.